Good morning, everybody. How are you? Well, thank you for coming. So today we're gonna talk about smart parking. I'm Remi Lorrain from Semtech. I am in charge globally of the LoRaWAN operator business development. At the LoRa Alliance, I have the pleasure to chair the LoRa Alliance operator community and the Success Replication Task Force. So what is the Success Replication Task Force? It's a group at the LoRa Alliance aiming to discover, to document how LoRaWAN is special for every use case. So we tend to build some cookbook or recipe for success, trying to understand why LoRaWAN is solving problems across the market, what are the business model, how LoRaWAN is unique across the market, what type of ecosystem we have to get into, where are the best experts in the world, and to illustrate what this Success Replication Task Force is doing, and how LoRa Alliance members are so special, are so unique. I have the pleasure to welcome 11X and John Cherewko. He is a senior key account executive at 11X, and today he's gonna talk about the smart parking application that 11X is able to deliver across North America. John, the scene is yours. I will let you introduce yourself, introduce your company, and the outstanding use case that you've been implementing across North America.
Perfect. Thanks. Morning, everyone. How are you guys doing? Good, excellent. It's a nice intimate setting here, so we can do this pretty engaging on the back and forth. So if you have questions, by all means, let's get to them here. So thanks for coming. Thanks for attending LoRaWAN Live. My name is John Cherewko. I'm a senior account exec with a company called 11X. As Remi had mentioned there, we're based out of Kitchener-Waterloo area in Ontario. So full disclosure, Canadian on here. I'll apologize a couple times, probably. Don't hold that against me, but it's just how we roll. If you weren't in the other session there, essentially the origin story of 11X kind of interesting. Bunch of original like OG type cell phone technology developers lost their jobs in 2014 when they were working for BlackBerry. As we all know, that company had a meteoric rise and then astronomical fall, or I might have reversed those. But the end result was the company not making cell phones anymore, and so you had all these experts in wireless technology, battery-powered devices, security and encryption, who suddenly didn't have jobs. So a bunch of them got together and started up 11X, kind of batting around the smart city notion in 2014, like what is this even? Get a lot of different definitions from a lot of different people. So they focused in on real-world applications, okay? So like how to deliver IoT solutions that are gonna make an impact. And so, in the other session there, we talked about, like with the city of Calgary doing stormwater monitoring and water metering and indoor environmental monitoring and a better mousetrap and, you name it, needle bin monitoring and that type of stuff. And so we've done it, waste bin monitoring. We've designed those solutions, from a device, and we do network operations and then application software for all of them. And the one that we landed on, which has produced like highly repeatable, highly scalable success, has been parking. And so we're going to talk about today how parking and how LoRaWAN specifically are such a great fit. Okay, so first off though, I got to share some really exciting news. The solution itself, our ExactPark smart parking solution, was just named IoT Smart City Solution of the Year by IoT Breakthrough. So we're very proud of that. There were entrants from, I think, 4,000 different companies from all over the world. And so this is being deployed as we speak. I'm going to give you some real-world examples. I don't have the live software for us here today, but by all means, I can make that happen if you're interested in the demo. So in the other session, then we talked about outcomes. So what outcomes are you always looking? We always start there and work our way back, right? So in terms of outcomes that you're looking to address, I mean, cities, campuses, small businesses, they all want to understand, like, how and when is the parking being used, And the way they do that currently is parking studies. So someone goes out there with a clipboard, and they literally write down how many cars, and so you kind of have a snapshot in time, and it costs you $60K for this report that has a couple days and a couple hours, and it's like mind-boggling. I think I got in the wrong business somehow. We joke around about that. But the fact is, it's a snapshot. It's not really fulsome in terms of like how and when and your parking assets are being used, right? And so that's like kind of where the data creation is like super important. And then cities and campuses want to make sure that there's accessible stalls, if there's reserved parking, EV charging stations, how and when are they being used, right? Well, people can say, well, you can tell because they're plugged in. But there's like, and I'm from Alberta out in Western Canada, and I don't know if they do it for spite, but every now and then, like a big F-150 will pull into that EV spot and just park there, right? And so, spite parking or whatever. So you're not getting a true reflection of like, how is that stall being used, right? If you're just relying on when it's plugged into an EV car. Of course, parking compliance generates revenue, not just on the ticketing, because of part of my learnings through this adventure have been, they don't want to write tickets per se. They just want people to pay for their parking. And that generates the revenue, because when you're chasing people with tickets and going to court and all that, you're just chasing money after money after money. So if you can just get them to pay because they know that stall is monitored and that's going to be highly accurate, then the compliance goes up, so your parking revenues go up for the city or the campus. And then of course for all of us, the most important thing, right? It's just finding those stalls, right? Where's the parking? And why when I drive into the airport, it says there's 52 stalls on this level, and then there's like 4, and like there's a car that's half in them and not, and whatever there, right? So there's a couple different ways to do these type of, in-out counts and red-green lights. You've seen those at certain areas, I'm sure, convention centers and all that. And they each have their pros and cons. For the LoRa, application and why it works so well, it just comes down to it being, and we'll get there. I don't want to steal my own thunder, but, as we compare against wired systems, it's night and day in terms of the cost. So here we've got like a basic system architecture, like the solution architecture. We literally, the sensor, which I've got a shot on here coming up, it's like a puck. We're Canadian again, so it's like a puck. It's about that size, right? They go in every stall. So in an asphalt environment, we literally core a 4.5-inch hole, 6 inches down, put the sensor in the hole, light it up, takes about 15 minutes, fill it with epoxy. And then for 10 years, that sensor is just gonna tell you if there's a car or no car in real time. And so like snow plows aren't gonna remove it, it can't be vandalized or stolen or anything like that. It's just gonna live in there with virtually zero maintenance for the next 10 years. If it's in like a parking garage environment, then we have a surface mount unit that goes, again, every stall. We don't put them on the ceiling. Sometimes people ask that. They're on the ground and whatever there. And then, so they basically, same thing, tell you car, no car. They communicate to the wireless gateways, so our friends at TechTelec and Curlink and other vendors, we use their gateways. And then the basic architecture sends that data to our analytics platform, which has got like all the reporting you can imagine, both showing you like in real time and historically, how is that parking being used? Days of the week, trending over months, that type of stuff. So your ECDev folks can say, yeah, you can see parking going up, or we don't have enough come festival season. How do we address that, right? So that's kind of your basic architecture. And then when you get to like extending that data to other areas, then we can put this stuff on like parking occupancy on digital signage. So at key intersections, you can see, I shouldn't turn right, I should turn left. There's 40 spots that way, there's none this way. Or I need an EV stall, they're that way. So visual cues as you're driving, super helpful, right? We have a navigation app. So you can put in your destination on the phone, select your spot, get turn-by-turn directions from the good folks at Google there, taking you directly to that spot. Someone takes your spot, takes you to the next available spot near that location. So now you're making real-world impact, because for the drivers out there, right, no frustrating circling, looking for parking, you're reducing greenhouse gases by up to 30%, you're improving roadway safety, and so these are the outcomes, right? So leading drivers directly to open spots. And there's certain places where, like Niagara on the Lake, when people go there, they come in from Toronto and from Buffalo and that, and they're driving around, they can't find parking, they leave. And this is like a known story. And so, being able to show people before they leave the home, like, don't go today, go on a Tuesday at noon, it's gonna give you better results or whatever. Or at least, hey, parking's a couple blocks off the main street, that's where you'll find it. So we're able to do that in real time with an exceptional degree of accuracy. So pretty straightforward there. We also have standard APIs. Every city and campus likes that so that they can integrate, because they already have existing parking systems. So whether it's a parking payment app, and then they want to put that live occupancy on their payment app, or if they have their enforcement folks want to see if it's a 2-hour zone and cars been there for 2.5 hours, they want that information. Then they can get it. So standard APIs for all that stuff. So now the good stuff. Why LoRaWAN, right? Well, it's a long-range, wide-area network. And so long-range in this application turns out to be about a half mile, 700 meters, and we can do that with a high degree of confidence. Like, that's us being conservative on the propagation. So that's from the sensor in the ground to the gateways that are on a street light or a lamp post or where have you, right? Rooftops, whatever there. So that long-range technology differs from some of the vendors out there who use Bluetooth. And we all know that, like, if I leave this room, my phone and my watch are no longer going to be connected via Bluetooth. So that's like the distance you get with Bluetooth versus LoRa. So that long-range component gives you a really scalable model and with less infrastructure requirements. The sensor that we have developed is the most accurate on the market at 99.5%. So, like, it's super accurate in telling you if there's a car or no car. And if that doesn't work, and that's maybe not really a LoRa principle, but if that doesn't work, or if it can't communicate reliably to the network, then everything downstream of that is going to be faulty. You just have bad data now, battery powered, we've got a 10-year battery in that device, and so again, it's going to be nearly maintenance free for 10 years. So that's key versus, like when you're in a parking garage environment, they've got the red, green lights. Well, they've also got conduit to every single one of those stalls, right? And so when you're running conduit, the cost goes through the roof. It's exponentially higher, right? And wires break. Any building operators know this, right? And so when you're dealing with a wireless technology, like when we're talking to people about this and they're not so sure about wireless, well, why wireless? And we're going, because it works. And it's essentially going to be maintenance free. You're not tracing wire to find out where that break is. So in terms of reliability, 11x, this is kind of how, again, the origin story we started. We deliver carrier grade connectivity by managing the network. So we have the device, we deploy the network, like the city or the campus will deploy it with our guidance, and then we manage it on their behalf. And so as a system operator, right, that's key, because the city then or the campus isn't having to figure out, like, how do I do LoRa? Now I need to hire an FTE or two to figure this out, keep my devices online. So as a service provider, we do that for the cities and campuses, which again increases your stickiness too, which is great. Of course, the other stuff we've already talked about, real-time data, deep analytics, all the way down to from the lot or the zone or the street, all the way down to the stall. How are my specialty stalls being used? Do I have enough ADA or accessible stalls or EV stalls? Do I have too many? How and when are they being used? It's key to have the data like that. Of course, the security, it's AES 128 from coast to coast. And so, delivering that type of, every city is going to try and make sure, you need to make sure that your solution's secure. And of course, the other way you can do parking is with cameras. But a lot of places, the cameras don't have the accuracy. Like, it's around 70% is the studies that I've seen. And so again, if you're only being able to deliver 70 or even 80% because they're affected by weather, by foliage, color of the car, make, model, that type of stuff, if it's raining, and so those types of things affect camera accuracy, and then, all the privacy type stuff that comes with it. So cities and all that type of stuff, they get concerned when they're like more cameras and it's more headaches. So having anonymous data, on the other hand, makes it nice and easy and clean. So why is that so compelling, right? Well, you know, I mean, for the reasons we just said, that's why. But what makes it so compelling, the sensor, like, we don't need to go in all the stuff on here, but like super ruggedized, you know, from minus 40 to you know, 176 Fahrenheit, you know, and LoRa certified and IP67 rated. So again, you know, the surface mount being on the right-hand side here just kind of bolts down, and the puck there on the left there, again, just gets fully embedded in the asphalt, you know, and then covered by that epoxy. You know, our team delivers carrier-grade connectivity. So what that means is, you know, when you're doing this for a city or campus is, you know, show them what that's going to look like. You know, how many gateways do we need? What infrastructure do we have access to? So if there's street lights or rooftops or that type of stuff, you know, so if you do that prop work for them, then you know yourself how many gateways you're going to need, and, you know, with redundant coverage, you know, we like to deliver so that your sensors are always going to, that mission critical data is always going to come through. So just a quick example of, you know, the prop studies that we tend to do in advance of actual deployments. And then shot of the dashboard here real quick. So I think the point that I meant to go through there was it's a complete solution. Like, it's the DNA of IoT, right? Everyone likes to say the device, the network, and the application software, right? So it's a complete solution. So the city is not just deploying devices, or, you know, it's a complete package solution that delivers value from coast to coast. So, you know, you can see the real-time occupancy over there, all the statistics. As you zoom down, it gets you all kinds of really interesting data, analytics. You know, this is in a loading zone where, you know, this is the occupancy. You can see at 8 a.m. and at 4 p.m. it kind of reaches that peak occupancy in that zone. And so this is of interest because during the day, those spots are underutilized. You know, so whatever policy and plan making, you know, the city is trying to do, you know, they can make, you know, policy and planning based on actual factual data, not anecdotal stories of, you know, oh, there's no parking. Well, we can see that there is, you know. And then dwell time. You know, the dwell time, you know, how long are people staying? You know, when shop owners, again, are saying there's no parking, well, or, you know, is it the staff that are parking out there all day long? You know, that shouldn't be. Well, you can see us, right? And it's very easy to see. So again, helping those cities with policy and plan making. Some of the APIs that we deal with here, you can sort of see there on the top right. Okay, so here you can see this lot is 72% occupied. Okay, but when we're pulling in live payment data as well from the mobile carrier there, like the mobile payment provider, it's Honk Mobile or something like that, and you can see it's only 40% paid. So now again, the city is able to find that, like, there's revenue loss there. You know, it's only 40, it's 70% occupied, only 40% have paid. You know, we should send some enforcement folks down there, you know, and get these people to comply. That's always the key, is to get them to comply, right? You know, and then having alerts in the stalls, you know, like not in each stall, but like, you know, setting a time limit either by zone or by stall. So like some of our users have alerts set because they have these, you know, the sensors in front of their fire hydrants. So if anyone parks there for more than 5 minutes, you know, the enforcement folks are on them, you know, and trying to change those behaviors, you know. 2-hour zones, you know, pretty common in your like trendy upscale districts, that type of stuff. You know, they want high turnover. They want people to come, shop, you know, sit on a patio, you know, live their life, and then move on so someone else can do the same thing, right? So in a 2-hour zone, which you can see here, you know, set limit 120 minutes. The actual for that car there that we're zoomed in on there is 131. So those type of alerts, you know, in real time, go to the enforcement folks, and then they can do smarter, more targeted enforcement, you know. And so, and then again, or they can change their policy. Maybe there should be a 3-hour zone. You know, I don't know, but at least they have that data to be able to make informed decisions. And then, of course, extending the data to like digital signage. So, we as a company, so digital signage, you can see two options on the left there. We don't manufacture digital signs, but there's a really great ecosystem out there. And so we can put this on the type of sign that the city wants or the campus wants. So again, at key decision points, you can make those decisions, with variable messaging and all that type of stuff. On the fancier ones that say, street cleaning, no parking, or snow removal if you're from the north like us, and or parking closed. And then the navigation app, this will be in full release in the Android store and in iOS in the next couple months here. It's just in final testing. So again, turn-by-turn directions. So you're not hunting for parking. So the user experience, which we talk about a lot these days too, right? Like the user experience. You want people to come shopping in this district. Well, make it good for them. Make it so they know they're going to have parking, right? Also, like we talked about, reducing those greenhouse gases. Improving roadway safety because people are going directly to spots and not looking, and all that type of stuff. And then public-facing websites. If you scan this with your phone, you'll get taken directly to the city of Oakville or the town of Oakville. Again, trendy, upscale kind of location just outside of Toronto. And this is their public website. So people can literally, take a look before they leave the house. So, and again, this isn't the full navigation app. That's not where you're going to if you're doing it. But this is just a public-facing website that'll show you in real time, where there is parking and where there is not. And so people, again, making those decisions before they leave the home. Don't want to park on this side or what have you. And in this particular case, like for example, there's a digital sign right here. As you kind of come off this road, there's a sign right here so that it tells you which way to go. And then there's one as you come down this road here at this intersection. Tells you again, if you're going left or right, how many spots are, and it's this guy like right here, so at those two intersections. So they update within seconds, it's awesome, and it's, again, super accurate, which is what, there has to be trust in the system. So the reliability and the accuracy of LoRaWAN, key, long distance, secured, non-proprietary, key, so that when, if a city is going to put up that infrastructure, those tectonic gateways or Curlink gateways and that type of stuff, sure, they can use our sensors, they can use our platform, or, hey, someone comes up with a better sensor, by all means, it's non-proprietary. So you can add in other sensors from other vendors, so there's no vendor lock-in, and which procurement folks in cities like this, they don't like. Okay, no one wants to be filling out the paperwork, sole sourcing stuff for the next, 10, 15 years or whatever. So again, and this is just like a sampling of our users right now, this project, you're gonna hear about this because you guys are all like tech folks. But in Arlington County, so just on the other side of the bridge, basically at Washington D.C., there's the super busy downtown corridor. We're doing a 5,000 stall pilot project. So those 5,000 stalls, we're in the midst of just deploying the gateways right now. And the sensors right now, and although not with all that weather they're getting, but and then what it's going to do is that occupancy data is going to improve traffic flow in a very busy part of the city by creating dynamic pricing. So there are going to be digital signs all around which tell people on the main corridor here, the busiest, most sought after parking, which we have the very accurate data to tell us, okay? That's going to be X number of dollars per hour, okay? If you park off street, X minus 1 or whatever, and further off, X minus 2, whatever that is. So this dynamic pricing that we're talking about, and it's not like Uber Surge or any of that type of stuff where changes by the minute and all that, but it gives us the very accurate means of data creation. We're pulling in all the payment data from all the other vendors as well so that we can correlate occupancy versus payment, so the on-street machines, your mobile apps, all that type of stuff, and then having a very fulsome look at the entire parking ecosystem in that area, and then hopefully pushing people off those main streets to reduce traffic and congestion, so again, reducing greenhouse gases. And so you're going to see all this. It's on their website right now. They've got a really interesting, welcome to this project type introduction. And but you're going to be hearing about this. No one's tried anything this ambitious since like SF Park. It was about that was about 10, 12 years ago, something like that. 10 years ago, I think they did. At that time, It was the same idea, but the sensors weren't robust enough and reliable enough to be able to last and or accurate enough. And so now that we've overcome this here, we're seeing this transition in the industry and real quick adoption in the last, like, you know, we've been doing this for 5 years, but in the last like 3, the smart parking has exploded, you know. And so, so as it comes down to, you know, why LoRaWAN and the LoRaWAN advantage, again, that long-range, low-power technology, battery-powered devices, we talked about that in terms of cost of deploying, ease of maintenance versus, you know, either cameras or hardwiring systems. So this long-range technology for sure facilitates that. Highly scalable and secure. I mean, the scalability, and this is one of those key things here where, like, we, you know, in my past life, I dealt with like water meters, you know, and so every home business, there are the water meters everywhere, right? So hugely scalable, and I'm directly responsible for hundreds of thousands of wireless devices being deployed across Canada and the States, right? And so that was kind of my background, and I was like, parking, I don't know, parking, you know? And, but you look at how many, there's 800 million parking spots in North America alone, okay? So if you start to do the math on that, like, well, if you know 10% of that and then maybe 10% of that, you still get to a really, really good number, you know, of like stalls that you could monitor. So hugely, hugely scalable, you know. We talked about already that as being like a non-proprietary open global standard, you know, great on the LoRa Alliance folks and Semtech and the originators, you know, for making that part of the you know, the package. So that there is a rich ecosystem. You know, this isn't an 11x like invention, you know, there's partners out there. We use other people's gateways and that type of stuff. And so non-proprietary, hey, one vendor's not doing their job, you know, get someone else in, right? Easy to deploy, you know, we talked about that. And, you know, solving real world challenges, you know, like climate change is real, you know, and that debate is done. And so burning less greenhouse gases, important, you know, and that user experience, you know, being able to get people to open stalls in real time accurately, you know, it can play a major role. And so we're real proud of the fact that we're using LoRaWAN to deliver this technology. It works, you know, so that's a key. You know, you don't want to have thousands and thousands of sensors out there and, you know, have all the headaches of dealing with that. And so we're happy to be deploying this all over the place these days. That's pretty much the content that I wanted to cover there.
Yes, thank you very much, John. Just the story of this panel. We had a phone call a few weeks ago with John. You know, the smart parking use case is a very early use case within the LoRaWAN ecosystem, but no player in the world was able to make it work 100%. On the sensor side, you can imagine how complicated it is to make your sensor work. Second, it has an impact on our life. And I was taken aback by the fact that 11X was able to solve the end-to-end problem. Sensor, road signs, platform, bidding, and I would say operation as well. And we decided to collaborate, that you come on stage. It's just awesome what you've been doing. You also moved and pivoted your business model. I remember 5 years ago, you were a public operator trying to deliver connectivity. And you became so passionate by your smart parking use case and the way you delivered that you decided to pivot and to become a solution integrator for smart parking. So also very smart move of the company. So if you have some question, feel free to John. Yes. So,
yes. I have a question. How are you dealing with parallel parking in non-marked spots?
Yeah, great question. So yeah, for the stalls to be, like for the sensors to be accurate, and I'm gonna back this up because I skipped over it, like how the sensor actually works, right? So when we deploy and we measure the center of the stall, Okay, I'll come back to your, there is no center if there's no lines, right? So the center of the stall we measure, and then we put the sensor in there, and it has a magnetometer, so when a big chunk of metal goes over top, that's the first trigger, but then there's a secondary radar that can measure, you know, how is this a big car, a little car, like what is, and verifies. That's how we get almost 100% accuracy on the sensor, right? Provided the vehicle's parked over top of it. So if there's no lines, right, then we're at the mercy of someone luckily or unluckily parking where they park, right? And so part of our solution, the short answer is, I guess, is we encourage all of our users to put paint lines, you know, and put these in spots where, or understand, if there are no lines, then we can't guarantee the results. If a car parks in between, you know, two sensors, then it's not going to catch it, right? So yeah, so lining the stalls is pretty key. Yeah, great question. Though.
I'm just curious, how much does the link between the sensor and the gateway get degraded, the RF link get degraded when you park a car? So now you have a sensor underneath of the car.
Yeah, exactly, right? That's what you know, because the signal has to get from there to the gateway. And so signal degradation, that's part of our network planning. And so I can't remember what the DBI are specifically, but yeah, you've got a big chunk of metal over top of your sensor now, and your sensor's in the ground, right? And so the specific RF friendly epoxy that we use is key, both for the magnetometer, the radar, and for the RF properties to the gateways, right? But we build that into when we do the network planning. And so as you guys all know, like in a perfect world, you can get like 10 miles between sensor and gateway, right? And so in this case, when you got a chunk of Ford or whatever on top of your sensor, that's when you get like approximately half a mile, and that's being conservative, right? And so that's how we model it out, just for sake of discussion here today, about that half a mile. Yeah. Great question.
How fast does it update?
Seconds. Yeah, so from the time to, and we can configure it. And we can do firmware updates and updates over the air and that type of stuff. But standard is around 30 seconds, you know, and if someone, for whatever reason, wanted it to update quicker, we could do that. Yeah.
So the polling frequency for each sensor is 30 seconds, and you still have a battery life of 10 years?
Nope, it updates on state change. So it's kind of just minding its own business. Until a vehicle comes over top, triggers the magnetometer, state change, right? Radar goes, state change. So that's how we get that 10-year battery life. And then once an hour, yeah, it checks in with the network. You know, I'm still here, I'm still going, still a car, you know? So car leaves, state change. Yeah, great question.
Sorry to follow up on that. So you're saying the 10-year battery life is only based on the state changes? Per day, what's the average to get that 10-year battery life?
Yeah, great question here too. So state changes, because it's a mathematical formula, right? So ours is based on 30 state changes per day, which is the highest in the business. You know, most other vendors have it around 10, you know, and so their 10-year battery, yet to be proven if it'll make it based on number of state changes, right? Yeah. Yeah. Over here. And this guy's, you're hired. You're hired. You work for us now. That's so yeah. I mean, without giving away too much, you know, it's on the roadmap. And I mean, cars have Bluetooth, right? Your phone has Bluetooth, right? Our sensors have Bluetooth in them as well. Absolutely. Yep. Yeah, you got a BLE. So if you're going to start or end session, so like you guys are going to see some really cool changes on how things happen in the parking world that are going to be super innovative, and so you know, keep your eye on that, because that's exactly a great use case and application. Yeah, I mean it depends, because when you look at it, it's like straight up 15 minutes from start to finish, so it's not as bad as what most people think. And when you get kind of like an assembly line going, they just bang them out, you know. And so when you look at the alternative of using cameras, then, which are going to be less accurate and higher maintenance, or look at the alternative of a surface mount, which is going to get scraped away by a snowplow. So in the northern environments, easy sell. You know, southern environments, you know, like we haven't pushed our way down as far and as fast yet, you know, because they don't specifically need this, like a subterranean model. But up north, it's just kind of like no-brainer because snow plows, you know. Yeah, great question.
You're saying, talking about snow, how do you handle when you have 6 inches, a foot of snow over the sensor?
Yeah, great. Yeah, great question. So we've hired people to do independent verification, validation. I've been on site, like I live in Calgary, Alberta, and we've got a good deployment in Edmonton and just outside Edmonton in Spruce Grove, so it's easy for me to go on site and check stuff out. And it's shocking, like that 99% accuracy is in all conditions, you know? So that means that like with the snow, still works, you know? And so, and asking, because I can't be there all the time, and our customer feed, and like even our independent folks that we send out there to go check, like they're not there all the time. So we rely on the city feedback too, check on it. And a lot of times like these get deployed, you know, of 50 sensors, you know, 100 sensors, because the city, yeah, they're gonna deploy these things and test them before, you know, they get budget, right? And then it goes to RFP and whatever it does there. But they want to test it first, quite often, at least anyways, before we see the full 3,000 stall procurement, you know, or 1,200 stall procurement or whatever. So, but to your question, doesn't really affect the accuracy. You know, as long as there's still lines, you know, or some visual cue like the parking blocks or whatever there, so people know, hey, this is a stall, you know, because in the winter that gets a little depending on your clearing schedule. So as long as they're parking over the sensor, we're still good. Yeah, no, great question. So challenges for us, like the status quo. So the red, green lights, people just know them, they're familiar with them, all that type of stuff, right? So like literally at Hamilton County, at the banks in Cincinnati, I don't know if anyone's familiar. See a couple of head nods there. The reds are at one end of the parking lot, the Bengals are at the other, and there's 5,000 stalls kind of just below there. And so there's a procurement right now for the red, green lights. And we've been working with them for 2 years on this, saying like, we don't do that, and here's why, and here's how you can do this better and for less money, right? And so we just responded to their RFQ, and we're waiting to hear back if they're gonna be okay with wireless versus a wired system. So we think we'll come in like significantly lower in cost should they okay it, because it's not the tech they expect, you know. So that's one of them for sure, is like, you know, dealing with the status quo out there, you know, what people are comfortable with. And a lot of the times we overcome that by saying, hey, well, let's do 50 stalls then. Pick a street, pick a lot, we'll do it, and then you're gonna love it, and then we'll expand from there, you know. So that's probably one. The other one too, I suppose, parking revenues aren't where they were, just from people returning to work and returning to the world and like shopping and being like that. It's been slower than what I think a lot of those folks would have liked. And so budgets aren't all fully restored just yet, you know. But again, that's two that I can think off the top of my mind there. So great question. Yeah. What do you think? Should we put these in at your transit stations, you know, so that people, you know, you want to get people off the roads, right? Use less, you know, burn less gas, all that, get them on transit. This is what all these smart city things, all these motion mobility things that I sit on, that's what they all say now, is we need more people taking public transit, right? Well, then at the stations where people are coming to parking their cars there, so we're going after a lot of those right now. We're like, sensor those up, make it easy for people to find parking, and then get them on public transit, you know, get them off the roads, you know. So with the concrete, no, we use a surface mount unit. And so you bolt those down, and or there's an adhesive. They take 5 minutes to deploy, like literally a QR code, scan it, calibrate the mag and the radar, and you're done. It takes 5 minutes. Like, and then you just open up the parking as you go. So again, key when you're deploying this stuff, the epoxy hardens in like minutes, you know, like 5 to 7 minutes, and then you can open up the parking as you go, so you're not disrupting the service to the residents and all that. So great question though, for sure. Oh, gets used once a decade.
Yeah, once a decade, and then we couldn't find it when it actually stopped.
Are we good on time? Is there
last
anyone
one,
in the
the
room
last one,
after
the
us?
last
Because I'm
one.
happy to do this all day. But we have one more question here. Sorry? Oh, yeah. Planning with the Public Works Department. That's how you do. You don't want to put these in the street that's going to get repaved next spring, you know. So we try to coordinate with them and then and then work through that and whatever there, because they can be removed, but it's not ideal. You don't want to start coring these things out. They can get damaged and that type of stuff. So it's just more of a planning exercise. Yeah.
Will they get destroyed with you?
Hopefully. I'm joking, but you can remove them, but we recommend just planning to not deploy if that road's going to be redone the next year or 2 years or whatever, right? So it's just part of the planning exercise of deploying in certain areas. Yeah.
In that scenario, wouldn't you have it deep enough that their overlay wouldn't affect them, even if they cut down and repave?
Yeah, so I don't have the shot of how it actually looks, but like it's only under like subterranean, like it's this deep or whatever, but the epoxy's covering like 3/8 of an inch, right? And so if you were to put like an inch of asphalt over top of that, then it wouldn't detect the vehicle, it wouldn't connect to the network, it would be buried in asphalt basically. Yeah. Yeah.
Cool. So thank you for your curiosity. It shows that your presentation was just inspiring, awesome. And so looking forward that you can reach out to John. But effectively, it impacts our life, right? We all struggle finding out parking lot. So it tells something to us.
Yeah, and I'll say, like, this is a great conversation. Again, thanks everyone for
Thank
coming.
you.
And if you live in a city or you deal with a campus, or, we are highly partner-centric, like our company is growing exponentially, but we can't be everywhere all at once, right? And so we partner with regional resellers and people that may have relationships and that type of stuff so if you think you may have a use case or an application,
Super.
come find me and we'd be happy to chat.
Congrats. Thank you.
Thanks, everyone.